Hello everyone and welcome back to the channel. In today's video, we are going to be taking a look at the intuition behind machine learning using the example of a simple linear regression analysis model which I'm going to be building in Microsoft Excel from scratch. I'm not going to be using any tools such as the Excel analysis toolpack for this video. If you're interested in learning about multiple regression or simple linear regression using the Excel analysis toolpack, I've made an entire series of that. I'll leave a link to the playlist. You can take a look at that. I'll leave a link in the description. I've also made a video on logistic regression using Microsoft Excel in case you want to learn that as well. So let's dive right into it and do stay tuned till the end of this video. So here I have a simple data set. You can see I have the hours studied and the score of the different students. So if a student has studied 2 hours, his score is 55. A student has studied 10 hours, his score is 95. So let us try to see if there's any relationship between the hours studied and the exam score, which is quite apparent if you look at this. But let's try to see this visually as well. So let's select these values and click on insert and hit a scatter plot. And here you can see there's a clear linear relationship. Okay, this will be more evident when we select the trend line. So here you can see there's a clear linear relationship. If the hours studied are more, you can see gradually the score also increases. So this line can be represented by an equation. Okay, in your college days you might have studied that the equation of a straight line is y is equal to mx plus b. Y is equal to mx plus b. So this is the equation of the straight line. Now machine learning is nothing but the machine attempts to find the most optimal values of the unknowns, that is in this case the slope m and the y-intercept b, so that the output prediction, that is y, is as close as possible to the actual values of the exam score in this case. Okay, so that is machine learning essence. Okay, and this concept can be applied to most of the machine learning models where you have different equations and the machine tries to find the optimal values so that the error is minimal. Okay, so let us take a look at this in a more deeper detail to get a better understanding of this intuition. So let us write this as the model here. Model. Okay, and let's take these values m and b, and let's say the machine initially assigns random values because it doesn't know what is the optimal values. So 1 for the slope and means for the y-intercept, we have assigned a value of 10. So let us see what are the predictions when the model has these values. So equal to, okay, let us take this independent variable multiply by the slope. Let's fix this, hit F4 because you don't want to this to move down when you drag it. So we'll give the absolute reference, the y-intercept, and hit F4. Okay, enter, and let's copy this down. So you can see these are the predictions made by the model for these values of the slope and the y-intercept. Now let us try to see how these predictions do. Okay, so let us again let us select the chart and hit chart design and go to select data. And let us add another series here. Okay, so the x, I'm going to take the independent variable, and for the y in this case, let us take the predictions, which is the values of the model, and hit on OK, and hit on OK. And now you can see here, let us hit a trend line again for this. And now you can see these are the predictions. And you can see the predictions are quite far from the actual values. Now the goal of machine learning is to find out the best values of the slope and the y-intercept so that the predictions are as close to the actuals. And then for future predictions, it will be able to generalize what is the best value of the equation so that the future predictions are very accurate. Okay, now how we can minimize this? So there's obviously some calculus and another math behind this, but the intuition is very simple. Okay, we'll try different values of m and b here to understand that, so that how you can minimize the distance. So how to calculate this distance first? To calculate the distance between the actual values and the predicted values, we can use something known as sum of squares. Okay, that is this value minus this value squared plus this value minus this value squared, and so on and so forth. So in Excel you can do this with a simple formula. So let us say SS is equal to, you can do this formula, sum x by 2. Okay, now select these values, comma, select these values, comma. This is the sum of square. You can see its value is 36,844. Now, again, as explained, the intuition behind machine learning is that the machine will aim to learn what are the best values of m and b to minimize the sum of squared. Okay, so I can try different permutation and combination. So here I'll say 2 and I'll say 20 and I'll see what is the minimum values. But you can see here this line is moving closer to this. But then after some time, it will move above this. So again, we have to find the best value so that it will come as close to this. And this involves many permutation and combination. This is a very simple data set. And also for a simple linear regression model, you can imagine how complex this gets for a larger data set and multiple variables. Okay, so there's complex math behind this, but this, in essence, this is the intuition behind machine learning. Let's see how we can achieve this using the Excel solver so that we don't have to try the permutations and combinations manually. So let's go to data and select the solver. Okay, this will do the permutation and combination for us. So what is the objective? The objective is the sum of square. And I want to minimize this as we discussed. We want to minimize the sum of square. By changing what values? Change the slope. And we want to change the y-intercept. Select this as GRG nonlinear and click on solve. Okay. Now you can see the sum of square is the minimum value. And this is your optimal slope and your y-intercept. And here you can see automatically now the trend line of the predicted values is closely and almost overlapping the trend line of the actual values. Okay, and which is quite apparent from here. This is your prediction made by the model. Now let us measure this model using something as the absolute error. So absolute error. This will help us understand the accuracy of the model. So we can say ABS as absolute, the model value minus the score value. Okay, let's copy this down. And a good metric is called the mean absolute error, okay, where we do the average of all the individual errors. Okay. So this is the mean absolute error. You can see it is 2.08. That means, roughly the prediction is either 2 points above or 2 points below. So you can see here the exam score is 50 and the model has predicted 52.9. Here it is 55. It has predicted 2 points extra again. 57. Here it is 65. In this case, it has predicted 2 points below. So it's very, very close to the actual score. And this model has generalized very well. So for future independent variables, you give a different R as the input variable, it will give you the proper predictions and which will be very close to the actual values. I hope you have understood the intuition behind machine learning in this video. If you did like this video, do leave a like and subscribe to my channel and leave a comment on any other videos or topics around data analysis that you want me to make. Stay tuned to my channel for more on data analysis. Thank you.